So question 1, a square was dilated by a factor of 5. The area of the image is 100 centimeters squared. What was the side length of the original square? So let's draw kind of what's going on here. We've got a square, and then it grows to become 5 times as big, and it has an area of 100 centimeters. Okay, so this is 5 times bigger, right? It says right here, k equals 5. So we want to know what is the original side length of this square. Now there's two ways to go about doing this question. So let's, well, I'm going to show you both, but let's start with one, right? So the first way we're going to do this is by saying, okay, well, we know k equals 5. So the ratio of all my side lengths is 5. But then what is k squared? Well, we're going to take that 5 and we're going to square it. That's going to give me 25. Okay, so 25 is the ratio of my areas. When my shape got 5 times larger, the area got 25 times larger. So if I want to know the original area, I'm going to take my new area and divide it by 25. That's going to give me 4. So my original area here was 4. So if you had to guess, what these side lengths are, well, you can probably guess it's 2, right? Because 2 times 2 is 4. If you couldn't guess, you could just have done the square root of 4. That will give you your 2. Okay? So that's your answer. It's 2. Now, if you don't want to go about doing that way, okay, and that doesn't make much sense to you, another way you could have done this question is by going, okay, well, let's look at my new area, that 100, and go, what are all of these side lengths, right? And if you had to guess, well, what times itself gives you 100? Well, that's just going to be 10, right? And if you didn't know that, you could do the square root of 100, and that's going to give you 10. Now, knowing that these new side lengths are 10, and they're 5 times larger than my original, then you're just going to do 10 divided by 5, your original k that was given to you in the question, and that's going to give you 2, okay? And that still comes out to the same answer here, okay? So 2 centimeters, 2 centimeters, okay? So that's question 1. Now on to question 2 over here, all right? So we have 2 similar triangles here, and we want to figure out what's the area x in the diagram below. That's the area of that original triangle, that bigger triangle, okay? So let's see here. We first want to figure out what the k is, and to find out what k is, we need, well, 2 corresponding lengths, right? And unfortunately, we don't have that in this question, but we can figure it out. Okay, we know this whole length here is 27, and this shorter length here is 9, which tells me that this longer length over here, okay, is going to be 27 minus 9. That's just going to be 18 meters. Now that we have these 2 corresponding lengths here, we can find out what k is. Okay, so k is going to be the ratio of your big over your small in this case. Okay, that's just going to be 2. So that means that this big triangle here is 2 times larger than this small triangle here, which, looking at it now, it doesn't really look like it, but let's imagine it is. Okay, let's pretend it is. So k is 2, which means that if this triangle is 2 times bigger than this triangle over here, then this vertical length is just going to be 2 times that vertical length over here, that height, right? So it's 2 times 1.5. That's just going to be 3. Okay. So we know that this is 3, this height is 3, this base is 18. So to find the area of this big triangle here, we can use base times height divided by 2. That's going to be 18 times 3 divided by 2, which is just going to come out to 27. All right. Now that's the first way of doing this question. Okay, the second way of doing this question actually is kind of, it's a little bit different, all right? What you're going to do is you're going to find the area of your original kind of right triangle that we have a lot of information about here. So 9 times 1.5, that's going to be 13.5, and we have to divide that by 2, and that's going to give you 6.75 meters squared. Now the original triangle, this area here, is 6.75 meters squared, and if we know that, and we know that k is equal to 2, then once again we will know that k squared, the ratio of my areas, is 2 squared, which is 4. So the area of this big triangle here is 4 times the area of this small triangle. So 4 times 6.75, that will get you right back to that 27 meters squared. Okay, so those two answers make sense because they correspond to, they agree with each other. Okay, so we're just gonna scroll right down here and circle C. Right, now question 3. So a regular nonagon, which is a polygon with 9 sides here, with side lengths of 12 meters each, is dilated using a scale factor of 8. So k is equal to 8. What is the perimeter of the image shape? So let's find the perimeter of the original shape. So we've got 9 sides. Each of them are 12 meters, right? So 9 times 12, that's just going to come out to 108 meters. So that's the perimeter of the original. Now if we want to know the perimeter of the image, we'll call that P prime. We're just going to have to multiply that 108 by the scale factor, which is 8, because we know that the image is 8 times larger than my original, which comes out to 864 meters. Okay, so that's going to be B. Moving right along then to question number 4. So we want to determine the values of x and y in the following shapes. The two triangles are similar. Okay, so let's start, I guess, by finding what the scale factor is. Okay, so let's look at, well, let's do big over small again. So 60 over 40, and that's just going to come out to 1.5. So from this red triangle to that blue triangle, we got 1.5 times larger. So if I know that my original kind of diagonal length here, that hypotenuse, right, was 50 meters, then that means that, well, in my new shape, it's going to be 1.5 times larger. So 50 times 1.5, that's going to be 75 meters. Okay, so this diagonal length here has to be 75 meters. But I also know that that 75 meters has to be equal to that 6x plus 15, right? That's what this kind of second triangle is telling me, is that this length here is 6x plus 15. So 6x plus 15 is equal to 75. Now let's use some algebra here. Okay, we're going to subtract 15 from both sides. That's going to give me 6x is equal to 75 minus 15. Okay, so 6x is equal to 60. So x is just going to be equal to 10. So that's what we're going to have, or we're going to get for that first variable. Okay, now to find what y is, let's do something a little bit different. Okay, just to show you guys a different perspective here, let's try using cross multiplication, shall we? So let's set it up in a way that we have it like, let's say red over blue equals red over blue. Okay, so if you have red on top, it has to stay red on the top on the second fraction, and if blue's on the bottom in the first fraction, blue has to stay on the bottom in the second fraction. Okay, so let's kind of redo the ratio here. Okay, we've got 40 over 60, right? Red over blue, 40 over 60, and is equal to, and now the side that I want to look at for my red here, okay, is going to be right here, right? This side with the y. So that's going to be 9y minus 6 divided by this right here, that 45. All right. So to do this cross multiplication here, we're going to start on the side of my unknown. So we're going to start on the right side. We're going to go diagonal. Then we're going to go straight down, okay, or straight up, depending on where you ended up after the first diagonal. So we're going to start going diagonal, then go straight up or down. So that means we're going to multiply here, and then we're going to divide there. Okay, so 45 times 40, and then divide by 60. That's going to give you 30. Okay, so 30 is equal to that on top, that 9y minus 6. Let's add 6 to both sides. You're going to get 36 is equal to 9y. And the last thing you're going to do is divide both sides by 9, which gives you y is equal to 4. And that's your second variable. Now question 5 over here is asking us to determine if the following triangles are similar. And what that means is that we have to see if these two triangles are proportional to each other. So to do that, we have to check if the scale factor for all of the corresponding sides are the same. Okay, so let's start with, I guess, the vertical side here. So let's say k is equal to 37.5 divided by 30. Okay, so 37.5 divided by 30, that's going to give you 1.25. All right. Now let's find the k for my horizontal lengths over here. Okay, so since I started with the big divided by the small. I'll do the same thing here. So that 25 divided by the 20, okay, and 25 divided by 20 should also give you 1.25. Okay, so far, so good. Let's check the last k here. So we've got 44 divided by 36, right? These two diagonal sides correspond to one another. And 44 divided by 36 gives you 1.22, repeating, which is not equal to these guys right here, right? So because the k's are not all equal to each other, then these two triangles are not similar. Side face, okay? All right, question 6. So triangle A, whose area is 16 meters squared, was dilated by a scale factor k. Determine the area of triangle B. Okay, so we have to figure out what that scale factor was. Okay, and to do that, we're going to use that formula here. K is equal to the image distance, okay, divided by your original distance. All right, and when I say distance, I mean distance from that center of dilation. Okay. Now, luckily we have the original distance already that's given to us. All right, so that's that number 10 over here. Now we want to know what that image distance was, and we can do that very simply by just taking that 10 and adding it to the 8, and that's just going to give you 18. All right, so 18 divided by 10, that's going to give you 1.8, right? So k is equal to 1.8, and if I know that the original area is 16 and the shape got 1.8 times bigger, then the area is actually going to increase by not 1.8 but 1.8 squared. So 1.8 times 1.8 is 3.24. So your area is going to increase by 3.24 times. So we're going to take that original area and multiply it by 3.24, which is your k squared. And that's going to give you 51.84 meters squared. And that's the area of triangle B. Now, last but not least, question 7. The city of Humville wishes to install a fence around two parks that are shaped in similar rectangles. Their dimensions are described in the figure below. The budget for this project is $55,000. Okay, so let's scroll down a little bit so we can see the whole diagram here. All right, so let's rewrite the information. We'll say budget equals $55,000. Okay. And actually, let's read the question because that might be important. So the fencing will cost $60 per meter to buy and install. Will the project stay within the budget? All right, so first of all, okay, before we even get to this whole fencing part here, we have to figure out exactly what is the perimeter that needs to be fenced. Okay, so we have to figure out the perimeter of those rectangles. And to do that, well, we have to figure out what those x's are. Okay, so that's step 1. Let's find out what the x's are. So let's start by finding what k is. All right, that could be fun. So k is equal to 105 divided by 35, and that's just going to come out to 3, which tells me that park 1 is 3 times larger than park 2. Okay, which means that this length right here, that 12x plus 24, is 3 times 5x minus 10, right? So 3 times 5x minus 10 is equal to 12x plus 24, okay? Now we're going to kind of distribute that multiplication here like a rainbow, okay? So 3 times 5 is 15x, and 3 times minus 10 is minus 30, and that's going to be equal to 12x plus 24. So let's do a little bit of algebra here. Okay, we're going to subtract 12x from both sides. So on the right side, that 12x is going to completely disappear, vanish. Okay, on the left side here, if we subtract 12x, we're going to be left with just 3 of those x's, right? And now let's do a bit more algebra. Let's add 30 to both sides. So minus 30 plus 30, that's going to completely cancel out. We're left with 3x on the left, and 24 plus 30, that's going to come out to 54. And now to find what x is, it's all just a matter of dividing that 54 by 3. So that's going to give you x is equal to 18. All right. And so now that I have x is equal to 18, I can figure out exactly what these lengths are here, right? So 12x plus 24, to find out what that is, we're going to do 12 times 18. Okay, let me write that down real quick here. 12 times 18 plus 24. Okay, and that's going to come out to 240 meters. And over here on the right, we're going to have 5 times, and we're going to plug in that same number, 18 minus 10. So 5 times 18 minus 10, that's going to come out to 80 meters. Okay. And so now we know this is 80, that's 35, that's 105, that's 240 over here. Okay, all we have to do is just add up all those sides and figure out what that total perimeter is. Okay, so perimeter is equal to 240 plus another 240, right? Because we have another length over here, plus 105 plus 105 plus 35 plus 35 plus 80 plus 80, okay? And so that's going to give you, let me just type this in real quick, okay? That's going to give you 920 meters. All right, now that we know that the total length around both parks is 920 meters, we have to go back down here, and we know the fencing costs $60 per meter. So the cost, okay, is going to be equal to 920 meters times that $60 per meter. Okay, so 920 times 60 is going to come out to $55,200. And let's look at the budget again. It was $55,000. Oops, we went over by $200. So the project will not stay under the budget. Okay, and that's all it is for question 7. If you have any questions, just let me know in the comments below, and have a great day.